Good evening, everyone. Am I audible?
Yes, ma'am, you are audible.
All right.
Good evening, ma'am.
Good evening. All right. So we will be looking at week 12 today. So in week 12, we are going to look at continuous random variable and few different types of distribution for continuous random variable, right? So mainly we are going to look at uniform distribution, non-uniform distribution, triangular distribution, exponential distribution, and normal distribution. Okay. So first, let's quickly recall what is a discrete and continuous random variable. Okay. So what is a discrete random variable? So a random variable that can take at most a countable number of possible values, right? So in that case, we say that it is a discrete random variable. So you see that it along the real line, only discrete points are taken. So if you have, this is the real line, then for a discrete case, it is somewhere like this. So only few points here and there. So like only a countable number like this is there. Okay. So for a discrete random variable, we define the probability in terms of a probability mass function. Okay. So what is a probability mass function? If you recall, a probability mass function describes the probability distribution of a discrete random variable. So for example, you see, if you have a following scenario where you are collecting the details of how many children are there per family. So you have some distribution like this, right? So in this case, what is that we see? P of x is always greater or equal to 0 and summation of all these probabilities is equal to 1, right? Summation of all this probability is equal to 1, right?
Ma'am,
Yes,
I'm sorry to interrupt. I just joined. What are we doing today?
we are looking at week 12.
Ma'am, did we just start or did I
Yeah,
miss anything significant?
just now we started. I just started with what is discrete random variable, recollecting discrete random variable, nothing new.
Okay, ma'am.
All right. So,
Hello?
yes,
Ma'am,
yes.
probability of x should greater than 0. It should not equal to 0. P of x.
Probability is greater than or equal to 0.
Ma'am, it should not equal to 0.
What is correct? It should be more than equal to 0 only.
What's your question? You are saying it should be a strict equality, like greater than 0. Is that what you're asking?
Yes, ma'am.
No, this is fine. P of x greater or equal to 0 is fine. Okay, so suppose let us say you have the random variables varying from 0, 1 to, so you are also considering the case 5, but in the case of 5, let's say the probability is 0, that is also fine.
Ma'am, not random variable. Ma'am, probability of the random variable should equal to greater than 0.
That is what I'm saying. So suppose in case, let us say I'm assuming the random variable 5. Okay. So it is okay. I assume that 5 is there in the random variable x and corresponding probability is 0. I can include this. So probability of x equal to 0 is possible, I'm saying. Okay. Got it?
Yes, ma'am.
Yeah. All right. So continuing with what is a continuous random variable. So a continuous random variable. So you see that when we cannot just count the number of outcomes. So in that case, we have something called continuous random variable. So usually we will be able to describe the possible values only in the form of an interval along the real number line. Okay. So in other words, continuous random variable can assume any value over an interval or intervals, right? So just like we describe a PMF for and the probability mass function for a discrete random variable, we are defining a probability density function for a continuous random variable, right? So every continuous random variable x has a curve associated with it. The probability distribution curve of a continuous random variable is also called its probability density function, and it is denoted by f of x, right? Now consider 2 points A and B where A is less than B. Okay. Now these are real numbers A and B, and A is less than B. The probability that x assumes a value between A and B is equal to the area under the curve between A and B. Okay. So this is from calculus, that area under the curve. How do you know? How do you find the area under a curve? Between 2
Ma'am,
points
by
Integrate.
integrate.
by integration, right?
Yes.
Yeah. So the same concept we are using here to define probability. So probability of A less equal to x less equal to B is integral A to B f of x dx. Right? All right. Now, what are some properties? So the properties you can easily correlate with the properties of a PMF. You can see that the values of the probability distribution curve of the area under the probability distribution curve. So the area here refers to the probability values, right? So you see that that value will vary between 0 and 1, right? Because you see that the probability, you know that it should be greater equal to 0, and you also know that the value, the sum of the total value, here in second point we are mentioning, the total value should be equal to 1. So the value area under the probability distribution curve for any of a continuous random variable between any 2 points. So first of all, here we are taking the points A and B. Between any 2 points, that should be between 0 and 1. Okay, so 0 less equal to probability of A less equal to x less equal to B less equal to 1. Right? And the total area under the probability distribution curve of a continuous random variable is always 1. Okay, so the total area in the sense over the entire R, if you are taking, okay, so in that case, f of x dx, this should be equal to 1. Okay, the total area. Right? Because the sum of all the probability in the PMF was 1. So here overall all the probabilities is equal to 1. Okay, integration of f of x dx. All right. Also, since it is a continuous random variable, so you should know that the area under the graph of the probability density function between points A and B is the same regardless of whether the endpoints A and B are themselves included. It means probability of a single point has no value for a continuous random variable. Alright. So for example, if you are just considering P of x is equal to A, then there is no value for just one point. Okay. So in this case specifically, whether you include the endpoints or not, the probability is not going to change. Okay. And the probability density curve of a random variable x is a curve that never goes below the x-axis. Why it cannot go below the x-axis?
And is it because the probability cannot be negative?
Yes. Okay. So you see that these are the 4 important properties of a probability density function. All right. Okay. So can you all try this simple problem here? So you see that let x denote the daily rainfall in mm. Now the PDF here given here is between 0 to 30 mm and the areas are here. These are the areas given to you. So let us say this is the PDF you have. So approximately I am drawing a PDF. So let me try to draw a rough graph. So let us say first I'll split it 5, 10, 15, 20, 25 and 30. Okay. And now the graph, let's say it's like this. So you have somewhere starting from 0 0.1, 0 0.2, then down up. Something like this is there. Okay. So here, this is 0 0.1. This is 0.2. This area is 0.3. This area is 0.15. And maybe here I should draw the curve a little bit differently because here the dip is coming. Something like this. I'm just trying to match with the values. So it's not something very specific, just to make sense of the values here. So again, it should go down here because here only very less. So here, let's say it's 0.05. Okay. So approximate graph. Okay, rough graph. So if you have this kind of a PDF, now find the probability that rainfall is less than 20 mm. So how do you find the probability in such case?
Addition of all the area
Ma'am,
below 20.
0.75.
Yeah, probability of, so here x is already mentioned, so probability of x less than 20. So it means we are just adding up everything. So 0.1 plus 0.2 plus 0.3 plus 0.15. What's the answer?
Ma'am, 0.75.
Very good. Okay. What about the second case? What is the probability that the rainfall is more than 15 mm?
Ma'am, 0.4.
Okay. So here you can say that probability of, so two ways you can do this. So here x greater than 15, you can either calculate directly from the graph. So here is 0.4. Okay, or you can also do 1 minus x less than 15. Either way it works. What about the last one? Probability of 10 less than x less than 20. How will you do this?
By adding the probabilities between 10 to 15 or 15 to 20.
Yeah. So probability of x less than 20 minus probability of x less than 10. Yeah. So from where does this concept come? Because this is something in general, right? So suppose you have something like here, this is 10, for example, and this is maybe A, B, let's use. So this is A and this is B, right? You want to find what is the area, this part of this part, right? Now this is going to be same as so this area minus this area. Right? So this is nothing but probability of x less equal to b, and this is probability of x less than less equal to or equal. So this does not matter. Okay, so it can be less than or less equal, they are same, right? Probability of x less than a, right? So this is probability of a less than x less than b. So if we use this concept, we can find it, or in this case, we don't even have to do this since the values are specifically given. Directly, we can look at the figure. If you directly find it from the figure, then what will you get?
0.45.
0.3 plus 0.15, right? So 0.45. Yeah, all right. Okay, so next we have what is called a cumulative distribution function, right? So just like see, the word cumulative means something accumulated, right? So here for a continuous random variable x, f of a, capital F of a is p of x less equal to a. So probability of x less equal to a. So everything till a is accumulated, right? Which is given as minus infinity to a. So all values till a. So minus infinity to a, f of x dx. Okay. Since the probability that a continuous random value variable x assumes a single value is always 0. As I mentioned, probability at one single point is always 0. So probability of x less than a is same as probability of x less equal to a. So these two are same. Okay. So this is integral minus infinity to a f of x dx. Okay. And how do you calculate the expectation and variance? The formula goes as follows. Okay. So expected value, expectation of x is integral x f of x dx, and variance is integral of x minus expectation of x whole square f of x dx. Okay. So you can see some similarity between what we have seen in the discrete case and here. Okay. So expected value and variance. All right. So now in this case, so next, okay. So now we are looking at a specific type of distribution. So for what we have seen what is a continuous random variable, what is the probability density function for a continuous random variable, and then we have seen cumulative distribution function, expectation, and variance. Now we will see each of this in different distribution. The first distribution we are going to see is a uniform distribution. Okay. So a continuous random variable has a uniform distribution. Okay, and it is denoted by u of a comma b. Okay, so for example, here over the interval a comma b, the values are all same. So let's say some c. So in this case, the function takes the value a in between, so c in between all the points a and b, and outside that it is always 0. Okay, now how do they come up with this value 1 by b minus a? Anyone who have already watched the lecture or from your own intuition, how do we come up with the value 1 by b minus a for a uniform distribution?
Then probability density function between point A and B is equal
Can you please be a bit louder? Is it just me for whom your voice is very low? Or is it for others also? Yes, sir. Sorry, I interrupted you because I could not hear properly. Yes, please continue. I'll try to hear.
And the integration between A and B, we will take to find the probability density function. And since it is a constant, then therefore its integration will be constant. Integration from A to B, limit will be A to B, and fx dx. Fx is a constant, therefore k we will take common, and its value will be x from limited from and its limitation limit will be from b to a. Sorry, A to B. Then if we find,
So
if it determine its integration, it will be B minus.
exactly. So here, so what you are saying is the main concept here to get 1 by b minus a, what we know is that over r, your f of x dx should be 1. This is what we know. And we know that over the interval a comma b, it has some value c, and outside of that it is 0. So only here it takes some value 1. Right? So this is equal to 1. So this is nothing but c times of integral a to b dx. So which is c times of b minus a. So your c should be 1 by b minus a. Okay. So this is how we get 1 by b minus a here for the uniform distribution. Okay. So for example, let us look at the graph of uniform distribution u1 comma 5. So between 1 and 5, it takes what value? What value it should take? So here your A is 1, B is 5. So what is your C? Your C is
1/4.
1/5 minus 1 is 1/4.
So 0.25.
25.
You see, this is 0.25. Okay. So we'll see another example. So graph of PDF of a uniform distribution now between -1 to 1. Okay. So for -1 to 1, now your A is -1 and B is 1. So your C is again 1 by B minus A. So 1 by 2. So it should be 0.5. Okay. So what is the PDF of a uniform distribution function? I hope it is clear for everyone. Okay. What about the standard uniform distribution? What does it mean by standard uniform distribution? Standard uniform distribution means, so for example, so here a random variable has a standard uniform distribution with minimum 0 and maximum 1. So the interval, instead of just considering any AB, we are specifically fixing the A and B values and as 0 and 1. Okay, so in that case, your f of x is 1 for values between 0 and 1 and 0 otherwise. Okay, so the value here b minus a is 1 and hence this value is also 1. Okay. All right. Now, what is the cumulative distribution function for a uniform distribution? So you see that for a cumulative distribution, here you see that f of x is 0 for x less than a, and for x in between a and b, it takes x minus a by b minus a. Okay. And then for x greater than or equal to b, it is 1. Again, here, what is the logic behind this? What is the logic behind this? Yes. Before a, what is the value of your function f? What is the probability before a?
0.
0.
So it means that here, when you are taking the integration, so what is the formula for CDF if you remember? F of x is, so for example here, integral. So here minus infinity
Infinity to a f
of
x.
x. Now in this region, the value of f is 0 and hence this is 0. And what happens to integral now a to b f of x dx? What is the value of f between a and b? 1 by b minus a dx. Right? And now what is 1 by b minus a dx? Now we are not calculating between a and b. Remember, we are calculating area between a and x because x is any value between a and b. So in this case, so we have to change this as t, let us say. Now what will happen? So when you integrate, this 1 by b minus a is a constant, and then here when you are integrating, it is t a to x. So it is x minus a by b minus a. So how did we get the middle part? Is that clear?
Yes, ma'am.
And the last one, why is it 1? Because after b, the values are anyway 0 for a uniform distribution. So it means now we are looking at the cumulative distribution function of the entire function, right? So in that case, what will happen? Entire area covered and hence the cumulative distribution function should be 1. For any value above b, the entire area is already covered and hence it is 1. Okay, so the CDF of a uniform distribution function, I hope it is clear for everyone. Yeah. All
Then
right.
can you explain the last part when x is more than b?
Yes. So what happens when x is more than b? So already you see that this is the part where you have the function value taking. And after b, you are looking at the area under b only because whatever point you are taking here, anyway, the values are 0 after b. So area between these 2 points together, if you add up all the area between this, it's already 1. Right? Got it?
Yeah, 1 plus 0 is like 1.
Sorry, what?
So it is like 1 plus 0. So that's why it is 1.
Yeah.
Okay, thank you.
Okay. So greater than b is integral of from b to again everything. So here you see that everything is now accumulated, and hence we see that this part is 1. Okay, since everything gets accumulated after b. Okay, all right. So now let's look at some specific examples.
Ma'am, is knowing the process important about how we got to the x minus a by b minus a?
Important in sense that if suppose let us say you forgot, then you should know what, see, it's not necessarily important about how the derivation, for example, in this uniform distribution case, the integration is very easy. But later on, for example, in the case of exponential distribution, the integration part is going to be difficult. So the important part is not about how you do the derivation of this integration. The important part is you remember the formula for the cumulative distribution function and this final formula. But in between, if you have to explain from where it comes, it is enough if you say that f of x comes from this formula. Okay, by substituting the value of f of x from the PDF, if you substitute it, we should get this. That much if you know, that should be fine. Because if simple integrations anyway you can manage, but if it is going to be a complex integration, you should at least know that this is what is going down in the background. Okay, because CDF, the basic definition, this one you cannot omit. So this is what is important. Okay, fine.
Yes, ma'am, got it.
Yeah. See, the other way, so whoever asked this x greater than or equal to b, the other way is that yes. So I guess what you mentioned as 1 minus 0, maybe this is what you are saying. So we are looking at 1 minus probability of x less than or equal to b or less than b. And we know that this part already is entirely covered, and hence we see that this probability is 1. Okay, fine. All right, so here cumulative distribution function of a uniform distribution u of 1 comma 5. What is the cumulative distribution of this specific function based on the above formula? Based on the above formula, how can you explain it? See here, your a value is 1, your b value is 5, right? So if your a is 1 and b is equal to 5, then what is your value of f of x for x less than 1? X less than 1, already you know that. For x less than 1, you know the function is already 0. Right? And then you are looking for x in 1 to 5. So between 1 and 5, what is happening? So it should be x minus, your a is 1 by b minus c. So it is x minus 1 by 4. This line is x minus 1 by 4. And then at last you have 1. So you see this is 1 for everything greater than or equal to 5. Okay. So is it making sense? So just applying the values of a and b in the above formula. Okay. So this is a visualization of the CDF of a uniform distribution. Okay. So similarly, you can look at the uniform distribution of the standard uniform cumulative distribution of the standard uniform distribution. So standard uniform distribution, you already know it is u of 0, comma 1. Since your a and b values are 0 and 1, so you see that this part is actually x minus a by b minus a. So which is x minus 0 by 1 minus 0. So it's simply x, right? So here you see that it is simply from 0 to 1, it is simply the function x, right? And then it is elsewhere 0. In this part before 0 and after 1 it is 1. Okay. Fine. Now, how do you find the expectation of a random variable x for a uniform distribution? Okay. Now, what is the formula for expectation? So, the formula for expectation, you know that is integral a to b x f of x dx, right? So, if it is x f of x dx, what is your f of x? What is your f of x?
This is in a constant value,
It is just,
just a constant.
which is 1 by b minus a, right?
Yes.
Yeah. So if it is 1 by b minus a, then let's take this constant outside. Now you have integral a to b x dx. What is the integration of integral x dx?
X square by 2.
Integral a to b 1 by b minus a. Now if you substitute the values, what will you get? B square minus a square, right? Whole divided by 2 times of b minus a. Now what is the formula for b square minus a square?
B minus AB plus A.
2 times of b minus a, so you can cancel them out. So you have expectation of x is equal to a plus b by 2. Okay, so the expectation part, is it clear for everyone?
Yes, ma'am.
Okay. So moving to the variance part. Okay, so now similarly, we are just going to substitute the values of f to find the variance as well. Okay, now how do you find the variance of this one? So for finding the variance, again, you can use this formula for variance which you have. So a similar formula for a discrete random variable is true in the case of continuous random variable as well. So variance of x is expectation of x square minus expectation of x the whole square. Okay, this is true in the case of both continuous and discrete random variable. Okay. Now here, how are we going to compute first expectation of x square? Because this part is already done. So let's do this part first. So here you have, this is equal to integral a to b x square. And what is your f of x? You know
1
that,
minus b by b.
yeah. So here your f of x is 1 by b minus a dx, right? So now this 1 by b minus a dx is again a constant. So you can bring it out. So you have integral a to b x square dx. Now what is integral a to b x square dx?
X cubed by 3.
X cubed by 3. And then you have to substitute a and b values. So you have b cube minus a cube by 3 times of b minus. And what is the formula for b cube minus a cube?
B minus A. B square minus A B plus B square.
B square plus a square.
So A square minus. Okay.
Right? And then 3 times of b minus. Right? Again, you can strike out this b minus a. So what is left? So b square plus a square plus ab by 2. So what is the formula for? So only we have calculated expectation of x square. So your variance of x is b square plus a square plus ab by 3 minus, you remember you have to do expectation of x square. So if you do that part, you already have b plus a plus b by 2 whole square. Okay. So if you do this simplification, you should get finally, what is the final answer for this? It is b minus a whole square by 12. You can verify this. Okay. So the simplification should yield you this answer. Okay. So this is for a uniform distribution. Okay. Fine. So the expectation and variance of a uniform distribution is fine for everyone, right?
Yes.
Okay, good. All right. So this is something I explained earlier, right? So probability between 2 points is probability of x less equal to b minus probability of x less than a. So this is the same thing I explained earlier as well. Okay. Now let us look at this specific exercise. This is very simple only. I just want everyone to try. Very straightforward exercise. See, this is a standard uniform distribution. So it's much simpler than the usual one. Yeah. What is the answer?
For first,
Mm.
it will be 0.6.
Yes. So why is it 0.6? Is it clear for everyone?
Yes, ma'am.
So it is 1 minus p of x less than equal to 0.4. So here you see that it's same. So here it is 1 minus 0.4. And why this is 0.4, that is also clear, right? Because it is a uniform random variable over 0, 1, right? So it means your probability value is just exactly the same. So here it is 0.4, 1 minus 0.4, and hence it is 0.6. So it's just calculating the area, right? So here you have 0, 1, and then here everything is 1, right? And you are calculating what is the probability of up to this part, right? What is this area? 1 into 0.4, so 0.4. Okay. Fine. What about the second one? This is much simpler. What's the answer?
0.85.
1.
Great.
Okay. What about the third one?
0.55.
Yes. So 0.75 minus 0.2.
0.25.
Okay. What about the last one?
0.5.
0.5.
Yeah. Okay. So you sometimes understanding the logic is important. You don't have to remember all the steps like calculations and everything. For example, here y 0.4, the logic you should know. Like when you try, you should be able to figure it out. Okay. That is the thing. So you don't have to memorize everything, but the logic you should be able to get it. Okay, so now moving to the next question. So this is more of a word problem. So whatever we have done here, now we are going to do as a word problem. That's it. Okay. So now suppose the time taken by a student to finish a quiz is uniformly distributed between 30 and 45 minutes. Okay, including 30 and 45. Find the probability that the randomly selected students needs at least 35 minutes to complete the quiz. How do we do this? At least means first of all, what is the meaning? Now, first of all, we have to fix a random variable x and we see that it is uniformly distributed in the interval 30 to 45. Okay, so this is your A and this is your B. Okay, now what is the thing we need to find for the first one? Probability of what? Probability of x. At least 35 means what?
Greater than equal to 30.
Greater than 35.
Yeah. So greater equal to 35. So which means 1 minus probability of x less than 35. And how do you find the probability for x less than 35? What is the cumulative distribution function? Do you remember?
X minus A.
So
X
it's
minus A by
x minus a by b
B
by.
minus A.
So here it is x minus a by b minus a. So here your x is 35, a is 30, then 45 minus 30. So you should get 5 by 50. Right? So you have 1 by 3. So 1 minus 1 by 3, 2 by 3. Is this fine? Yeah. All right. Now, what about the second one? What is it we need to calculate? Probability of 35 less equal to x less equal to 40. So here, using the previous formula, this is x less equal to 40 minus probability of x less equal to 40. So what is p of x less equal to 40? 40 minus 30 by 45 minus 30. And here we already have calculated this part, which is 1 by 3, right? X less than 35. So here it is 10 by, maybe 10 by 15 minus 1 by 3. So 2 by 3 minus 1 by 3. So the answer is 1 by 3. Is this fine?
Yes, ma'am.
Yes.
Okay, good. Okay. So now we have seen uniform distribution. So in next we will be moving to non-uniform distribution. So in uniform distribution, first we saw what is the PDF of a uniform distribution and PDF of a standard uniform distribution. Then we saw what is the CDF, the cumulative distribution function. And then we saw some examples to understand the formulas, right? Okay. Now, what about the non-uniform distribution? So, it is something like this. It is not uniform. That's it. Okay. So, suppose that the number of minutes of playing time of a certain college basketball player is randomly chosen game has the following density curve. So, this is the density curve you are having. So, for a density curve, what are the properties it should satisfy? Can you recall? What's the first one?
And total area should be equal to 1.
The probability of between any 2 points should lie between 0 and 1.
0 and 1.
And
Total area under the curve should equal to 1.
that should be 1. Right? So here, what is the total area? How do you find the area in this case? Suppose I am going to split it into 3 parts. Let us say this is one part and this is another part. This is another part. So what is the area of each part? Let's call this 1, 2, and 3. What's the area of first part?
2.5. Sorry,
Minus
0.25.
10 into 0.025, which is 0.25. What's the area of second one? Calculate in the same way.
0.5.
Third one, again the same point.
0.5.
So the total of all this value is 1. Right? So it satisfies both the conditions. Right? Okay. Now find the probability that the player plays over 20 minutes. So over 20 minutes means which area we have to include?
2 and
To
3.
40.
Yeah, so 2 plus 3. So which is what is 2? We have already calculated 0.5 plus 0.25. So 0.75. Right? And if it is less than 25, we can write it in this way. Is that fine? 25 is half of this 2 by 2, this second part by 2. Is that fine?
Yes, sir.
Yeah, so in that way, it will be 0.25 plus 0.5 by 2 again, it is?
0.25.
So total is 0.5. Okay. What about between 15 and 35? So 15 and 35. So it means we have half of first part, entire second part, and half of third part. Right? So this means 0.25 by 2 plus 0.5 plus 0.25 by 2. So again it is 0.75, correct? Yes or no?
Then why we are
Yes,
taking second one, the probability is 0.5.
Yeah,
We are considering this.
that's what?
Between 15 to 35, only half of the second part and only half of the third part we should consider.
Why
Then-
is it that way? See here, what is that we are doing? So here you are having something
Okay,
like
ma'am. Yes, ma'am.
Got it, right?
Yes, ma'am.
we are considering all this part here.
Yes, ma'am.
So because of that, since we are considering all this, it's like this. So 15 to 35. Okay. What about more than 35? It should be half of which?
Half of the 30 to 40 from third part.
So what is half of 0.25? Okay. Fine. This question is fine, right?
yes,
Okay. Okay. So this is now triangular distribution. Okay. So now for this triangular distribution, here is this example we have. So assume that now it is 2 p.m. and John is planning on studying for her statistics test until 6 p.m. when she will have to go out for dinner. Okay, so let's say she probably know how the interruptions are going to be there, and this is the curve for her study pattern for the next 4 hours. So does anyone really do such things? Study pattern, draw a graph. Okay, just for purpose of having an example, we are having this.
Madam, what is the formula for expectation and variance of the non-uniform distribution?
Sorry, what?
No, like we did not discuss the formula for variance and expectation of non-uniform distribution.
No. This we have not discussed because see, non-uniform distribution does not have a fixed pattern. Same way, triangular distribution does not have a fixed pattern. Triangular distribution can be right angle triangle or can be isosceles triangle. It can be different type of triangles. So there is no fixed formulas for PDF or other things, CDF expectation.
We can replace the equation of fx like this triangle. I can make combination of two straight lines, right?
Yeah, that is the thing is that is true only when it is a right angle triangle. But see, the triangles can be of different shapes. So even this kind of a triangle is possible. So many different kind of triangles are possible. So it depends on the specific triangle you are considering.
Okay.
Okay. Sorry. All right. So yeah. So in that case, 6 p.m. First of all, it has 4 hours, and hence now we are considering our random variable x 0 to 4 hours. Okay, so the study time is from 0 to 4 hours. Okay, and this is the curve we have. What is the height of the curve at the value 2? Okay, so we see that. So here for the first one, first note that the triangle is symmetric about 2. So which means here we have a right angle, right? So here you have a right angle. Okay, so if it is a right angle triangle, what is that, about the area? So area of triangle is
into base into
half BH, right? So here, what is your base and what is your height?
Base is 2, madam, and height we have to identify.
Yes. So here, height is what we need to find. So this part here, this, okay, this is your height. Okay, so that is what you need to find. Okay, now for this triangle, the base is, what did you say for the base value?
2.
Why it is 2?
Then 4.
For the
4,
entire,
ma'am.
4, ma'am.
for the entire triangle, the base is 4, right?
Base is 4.
Yeah. So this is the entire triangle, and this is the base, and this is the height, right? So this is the base. From here to here is the base. Okay. So in that case, you have half, your base is 4, and you don't know the height. Okay. But what is this area of triangle representing?
1.
One.
Yes.
The probability distribution function is
Total
1.
should be.
Right? Because we know that this is nothing but 0 to 4 f of x dx. That should be 1 because it's a density function. Right? Now, because it is 1 here, so what should be your h from this?
2.
Your h should be 2.
2, madam.
1
2.
by 2.
Half 0.5.
0.5. Right? It is 2 by 4, so it is 0.5. This is 0.5. Okay? Fine. Now, if this is 0.5, let's try to answer the next part of the question. What is the probability she will study more than 3 hours? Okay. So, half of 0.5 here is 0.25. Okay. The probability that she will study more than 3 hours is this part. Right? What is the area of that part from the graph? Again, it is
0.125.
1 into 0.
it is again a right angle triangle. So base is 1, height is 0.25.
0.25.
So here again, half base is
Both
1,
0.
height is 0.25. So 0.125.
125.
Okay. All right. Now, what is the probability that she will study between 1 and 3 hours? So for this part, let's try to do the following. So for the third part, see, let's say this is the graph. Right? So this is your
1
1.
minus into this, madam.
Sorry, what?
We can do 1 minus 2 into 0.125.
1 minus?
Like 1 minus the area between 3 and 4 and 1 and 2.
Then 1 minus area of one triangle that we have found on.
Oh, yes, exactly. Yes, that's what we have to do. Yes. So for finding this part, we already know the area of the other two parts. So what we can do is that, so here 1 minus, already we know this part is 0.125 and it is symmetric, and hence this is also 0.125. And so it is 0.125 minus 0.125, which is
0.75.
Okay. Right. So this is again something based on the graph you are having here. Okay. So based on the graph, this is the observation we have. Okay. So this problem, I hope it is clear for everyone. Shall we move to the next one?
Yes, madam.
Okay. Okay. So now the exponential distribution is something a little bit, you can see that it is involved compared to uniform distribution, right? It was much simpler. Now here you have a function which involves lambda into e power minus lambda x, where lambda we call it as a parameter. Okay, so the lambda will be changing for different problems. Okay, so lambda is a positive parameter. Okay, so your f of x is lambda e power minus lambda x for x greater equal to 0, and it is 0 otherwise. So this is what we call as an exponential distribution, and it looks like this for different values of lambda. Okay, so for lambda equal to 0.5, lambda equal to 1, lambda equal to 2, and so on, it looks like this. Okay, fine. Now, this is the PDF. Now, what is the CDF? The cumulative distribution function of an exponential distribution. So, you know that this is the formula, right? So, now only between the values 0 to a, the function is lambda e power minus lambda x, and for other places it is 0. If it is 0 for other places, now how do you compute this integration? Yes, how do we do this?
Then lambda is constant. That's why we can take common.
Yes.
The integration of e power minus lambda x is equal to e power minus lambda x upon minus.
e to the power lambda x square.
Again,
The
it is
integration.
minus lambda
e to
x
the minus lambda x
upon
by minus lambda.
0 to a.
So now this is again
E power minus lambda a.
so lambda a minus e power 0, so 1, and then you have minus lambda here, right? So lambda, if you can cancel out, then if you subtract the minus, you can rewrite it as
1 minus e to
yeah, fine. So this is f of a. So if this is f of a, then what should be a f of x? 1 minus e power minus lambda x.
minus lambda x.
Okay, fine. Okay, so this is the cumulative distribution function of exponential distribution. Okay, so here is the graph. Okay. All right. So now we have to find the expectation and variance. As I mentioned, just for the uniform distribution, the computations were much simpler. But here it is going to be a little involved. So it's not a big deal. You can still work out the steps. Because in basic calculus, I guess you have done this in very, like maybe in grade 8, 9. What is this called? Integration by parts. Yes, even here it is mentioned. So this integration by parts, like integral, you take the integral as integral u dv, and then you write it as uv minus integral v du. So you have to apply that concept here. So to find the expectation and variance. So the usual formula for expectation and variance, you can write down step by step. It's just that the computations are going to take some time. Okay. So here, this is the expectation and variance of a exponential distribution. Okay. So you can all try it out. Those who are interested, you can try out the derivation. And if you are having some issues, maybe we can discuss during the doubt session as well. Okay. So if those who are interested, if you want. Okay. All right. So here you see that this is again some property which can be used maybe for some specific uh, examples maybe. So even here for finding variance, you see that this particular part is handy because expectation of x square is 2 by lambda because n is 2. So 2 by lambda into expectation of, so let me write it down. So expectation of x square is 2 by lambda times of expectation of x, right? So 2 by lambda, this looks like x. So 2 by lambda into expectation of x. So 2 by lambda square. So now variance of x is expectation of x square minus expectation of x the whole square. So 2 by lambda square minus 1 by lambda square. So 1 minus 1 by lambda square. Okay. So here you can easily remember. So here the exponential for expectation it is 1 by lambda, and for variance it is 1 by lambda square. Okay. Fine. Okay, so here is an exercise for exponential distribution. Can you all give it a try? Suppose the length of a phone call in minutes is an exponential random variable with parameter lambda equal to 0.1. If someone arrives immediately ahead of you at a public telephone booth, find the probability that you will have to wait more than 10 minutes, between 10 and 20 minutes. What is the PDF? Do you remember?
Minus e to the lambda.
Okay, so this is the cumulative distribution function. Use this to find the answer. So more than 10 minutes means what is that you need to do? For the first part, probability of x greater than 10, which means 1 minus probability
Hence,
of,
probability of x less than equal.
right, which is 1 minus e power, here lambda is 0.1, right? So your x is 10. So if your
10.
x is 10, so what is the answer then? E power minus 1 simply, right?
We do per minus.
Okay, what about the second part? Probability of 10
10
less
than
x.
x plus.
What is this? So
Probability
probability of
of x less than 20 minus probability of x less than.
So again, this is
1
1 e power minus 2 minus 1 minus e power minus 1. So you have 1 and 1 will get cancelled. So you will have e power minus 1 minus e power minus 2. Right?
Yes, ma'am.
So this problem is fine for everyone, right?
Yes, ma'am.
Okay, good. Okay, so next we are going to look at a important distribution, which is the normal distribution. Okay, so what is the PDF of a normal distribution? Okay, so we are seeing slowly we are progressing to something complicated, right? So the functions are very simpler in the beginning for uniform, then for exponential, we had one parameter. Now we have two parameters. So the first one is mu and the second one is sigma. So mu is the mean and sigma is the variance. Okay, standard deviation. Sigma is the standard deviation and sigma square is the variance. Okay, so we are having two parameters. So usually normal distribution, we are representing using n of mu comma sigma square. Okay, and the density function is given as follows. F of x is equal to 1 by square root of 2 pi. See, remember sigma is outside the square root. Only 2 pi is inside the square root. Okay, and then e power minus x minus mu whole square by 2 sigma square. Okay, something to memorize. Okay, fine. Now, to understand the shape, that is very crucial. The normal probability density function is a bell-shaped density curve that is symmetric about the value mu. Okay, symmetric about the value mu is again very important. So it is a bell-shaped curve, symmetric about the value mu. Its variability is measured by standard deviation sigma. Okay, how is it varying? We usually measure it by sigma. You'll understand this line slowly. So first let's try to understand the height of this curve. Okay, so here the height of the curve above the point x here, you see that particularly in the case now we have taken mu as 2. So this is your mu. Okay, and your sigma is taken as 1. In this case, the height is 0.399. How is that so? So here, can you all compute the following? So now 1 by square root of 2 pi, sigma is 1. And then here e power, here x is mu. So here this value becomes e power 0. So simply 1. So what is 1 by square root of 2 pi? Can you all compute? What is the answer? So How many of you computed? What's the answer for 1 by square root of 2 pi? No one? Just a simple computation. Why it's taking so long?
Madam, how this term became 1? E to the power minus x minus b.
X is equal to mu. So in the numerator it is 0. E power 0.
Okay. It's taking time to understand, ma'am, because it's
Okay.
complicated.
Oh, got.
Coming out to be 0.39.
Okay, good. So it
Eight.
is 0.3989.
1 by
Yes.
So let's say 0.399. So which is the height. Okay, so how did they get this height? Is that clear for this particular scenario? Let's look at another example. So again, here, this is your mu. Your mu is still 2, but now your sigma is 0.5. Now what is this height? Okay, so now what is this height? So now 1 by square root of 2 pi, your sigma is 0.5, right? And then here you see that this e power again minus 0. So again, simply 1 by square root of 2 pi. And then here x is equal to mu. Okay. And then here into 0.5. So into 0.5 in the denominator is same as, by mistake I'm repeatedly pressing this. Where we, yeah. So now here you see that it is 2 times of 1 by square root of 2 pi. So the answer is 0.798. Okay. How did we get this? Is that clear? So just the change of sigma here. Okay. Yes.
This height will always be maximum at the value of mu.
Sorry, can you please repeat your question?
Like we are getting the maximum height when x is equal to mu. So is it the always case, or we can also have like
Yes, for normal distribution, that is the usual scenario. The maximum height is when you have x is equal to mu and the graph will be symmetric about that point.
okay.
Okay, so this is the usual scenario for a normal distribution. Fine. So here you see that for same mu and different sigma, this is something very important to understand. Okay. See, what is the sigma representing? The meaning of sigma, the standard deviation. It tells how far your data is spread across, right? So now, for example, the mu is same. The mean value is the same in all the 3 data set, right? So in the first case, this one, so let us say this is the first one, second one, and third one. So in the first one, you see that there is not much deviation. The data are not very much spread across. So you see all the data mainly, they are lying between these 2 points. So this, most of the data points for the first case lies between this small interval, right? And then you see when sigma is equal to 1, then what happens? Now you see that it is a little bit more now. Right? And when sigma is 2, it's even more spread across. So you see now the values are like this. Okay? So the values are getting spread across more and more. Okay? So the meaning of standard deviation, you can understand it from this graph. Right? You can correlate it with this graph. Okay, the larger the sigma, also the curve is getting flatter and more spread out. Okay, fine. Now same sigma, different mu. Okay, so now you see that this distance is same for everything because mu is also the same. Oh, sorry, mu is just the mu is different. The sigma is same. So the spread is the same. Okay, only the mean, the position of the mean is changing. Okay, it's just like shifting of the same graph in different position, right? Okay. So symmetric about around mean is something very important. The probability density function of a normal random variable x is symmetric about its expected value mu. It follows that x is equally likely to be on either side of mu. Okay, so this means what? Probability of x less than or equal to mu is same as probability of x greater than or equal to mu. So it is half. Okay, exactly half. Okay. So in general, this is how you can view your probability distribution function of a normal curve. So the top point here corresponds to mu, the mean. And then mu minus sigma, mu plus sigma, mu minus 2 sigma, mu plus 2 sigma, mu minus 3 sigma, and mu plus 3 sigma. And after that, almost nothing. Almost nothing in these two places. So probability that you find something after these 2 points is almost 0. Okay. So what are the observations from this curve? It is a bell-shaped curve. It is centered at mu and close to the horizontal axis outside the range mu minus 3 sigma to mu plus 3 sigma. See, it's almost flat. The curve becomes almost flat. Close to the horizontal axis in the sense that you see the curve is almost flat. Right? Outside mu minus 3 sigma and mu plus 3 sigma. Okay, so these are the important observations from this graph. Okay, so far whatever we have seen normal distribution, about normal distribution, is that clear? Shall we proceed? Yeah. Okay. Okay, so now for computational purposes for doing problems, the following values are going to be very useful. Okay. So here these values are approximated. Remember, these are not like fixed values. These are approximated values. Okay. So what is the area between these 2 points? Mu minus sigma and mu plus sigma is 0.68. So this part here (0.68). Okay. So that take any point and if it lies between mu minus sigma and mu plus sigma, the probability is 68%. Right? And you see similarly probability of mu minus 2 sigma and mu plus 2 sigma is 0.95. Right? And probability mu minus 3 sigma and mu plus 3 sigma is 0.997. So you see that outside this mu minus 3 plus sigma and mu plus 3 sigma is almost 0.003. So which is almost like 0. Right? So usually probability of x greater than mu plus 3 sigma and our probability x less than mu minus 3 sigma is usually considered as 0. Okay, approximately. So this is usually what we consider. Okay, fine. So these values are something you should remember. These are very important for doing problems. Okay, so let us do some problems. We'll try to write the values again and again for memorizing the values. Okay, so the standard normal distribution is now the next thing, which is very, very important because that is what we are going to use very frequently. Unlike the standard uniform distribution, we did not see much of standard uniform distribution application later on. But here you see that the standard normal distribution has something really important from now on. Okay, so here when mu is equal to 0 and sigma is equal to 1, in that case, a normal random variable having mean value 0 and standard deviation 1 is called a standard normal variable. Okay, and it is represented by 0. Okay, so Now, in this case, the density curve is called the standard normal curve. And here, instead of x minus mu and x plus mu, not x minus mu minus sigma. So this is mu minus sigma and mu plus sigma, because mu is 0 and sigma is 1, right? And this is mu minus 2 sigma and mu plus 2 sigma. This is mu minus 3 sigma and mu plus 3 sigma, right? Because here your mu is 0, sigma is 1. So this is the curve. Okay, fine. Now, note that in the following case, we are going to look at what is the probability. Note that it is not x, it is z. Okay, we are going to look at the probability of z rather than x. Okay, now what is the probability that the random variable z lies between -2 and 2? What's the answer? Directly from the graph, right? Directly from the graph, you see that between -1 and 1. So here, probability of values between, this is 0.68. Probability between, this is 0.95. Probability between, this is 0.997. So the answer for this is already there from the graph, right? Okay. What about the next one? How do you obtain the next value? Can anyone tell? Probability of z greater than -1? Anyone?
0.68.
Yeah, continue.
0.68 plus half of the 0.95 and 0.997.
Yes. Okay. So 0.68. So the half values are already mentioned here. You see 0.68 and then 0.135. So this 0.024, yeah, you have 0.135. Then 0.124, right? 024. So what is the sum of all these values? Can you calculate and quickly check?
Zero 0.839.
0.839, right? Okay. So you have, this is approximate 0.839, so approximated to 0.84. Okay. All right. What about the next one? Probability of z greater than 1. There is something very important you should observe from the above graph. So probability of z greater than 1, okay, z greater than 1 here. Is it same as probability of z less than -1?
Yes.
Yeah.
Yes,
So note, so there are several ways, just like we did in the previous case, we can like adding the values also we can do. Just to note that this is also possible, I'm saying. So probability of z greater than 1 is same as probability of z less than 1, less than -1. So which is 1 minus probability of z greater than -1. So it is 1 minus 0.84, so 0.16. Is this fine? Yeah. This is fine, right? Or you can add like in the previous case also. Either way can be done. Okay, fine. Now what is probability of z greater than 3? As I already mentioned, it is 0. Right? X greater than mu
0.
3 sigma and x less than mu minus 3 sigma we consider as 0. So here in that case, for a normal curve, probability of z greater than 3 and probability of z less than 3, we consider it as 0 usually. Yes?
The probabilities 0.95 and 0.997.
Yeah.
How we are how we can say that this is a probability of -1 between -1 and 1 and 2 and -1.
So how are we getting these values? Is that what you're asking?
By graph, how we can see that these are the probabilities between -1 and 1 and -2 and 1.
Oh, these are like values already computed based on some this formula, whatever we are having here. So based on that, it is already computed and given to us. We are not doing anything from the graph. It is already given that between these values, this is the value. This is kind of already computed and given to us, not from the graph it is mentioned. Okay. So
And the arrow is showing from 1.5 to -1.
this arrow is misleading. So this is a misleading graph. So this is the exact meaning of this. So here maybe I should put like this. This is misleading. Okay. So here up to this. Okay, now it's okay, right? So it's exactly the same way it is mentioned here, just that the arrows are misleading here. Okay, now is it clear? Okay, fine.
Ma'am, these values are given for this question only, or
This is fixed.
this is
This is
fixed
fixed.
for in all cases.
Yes. Whenever your x is, you have mu is 0 and sigma is 1. This is the standard normal curve, and for a standard normal curve, these are fixed values. Okay, so this as well as this in the case of x. Okay, this is fixed. Okay, and what is probability of z less than 2? So from the graph, if you want to calculate, you can do. How can you do? X less than 2. So can we just do 1 minus 0.024? Yeah. If we do 1 minus 0.024, what do we get? 976. Okay. Fine. So how are we getting the probability for the standard normal curve? Is that clear so far? Yeah.
Yes.
Okay. Okay. So this is the first property we are seeing. Probability of z less than minus x. Okay, is 1 minus probability of z less than x. Why is that so? First thing you need to observe is that probability of z less than minus x is same as probability of z greater than x. This is the first observation. And because of this we can write as probability of z less than minus x is 1 minus probability of z less than x. Okay, fine. Next, property 2 is very much similar to what we have seen earlier. So probability between two values A and B.
Please
Yeah.
show the previous one.
Yeah.
And here, probability of z is less than minus x is equal to probability of z is greater than x.
Yeah.
This part is clear.
Hmm.
But why it is equal to 1 minus probability of z less than equal to y?
This is the usual thing we do, right? Probability of z less than x is 1 minus probability of z greater than x, or maybe here the other way around. So z greater than x, right? Because now the entire interval is between minus infinity x this. Now you want to look at everything greater than x, right? So in that case, what I am doing, I am splitting this as the entire thing minus this part. This is a usual thing we do, usual trick we do for probability, right? 1 minus, so probability of A is 1 minus probability of A
Yes,
complement.
ma'am, this is clear.
Yeah.
But we are finding the probability for which part of the curve that is equal to 1 minus probability of z.
What is the confusion here?
Uh, these probability of z is equal to z less than minus x is equal to probability of z greater than z greater than x.
Yeah.
Both parts are same. Probabilities for both the parts are same.
Yes.
Then how it is equal to 1 minus p of z less than x?
See here, z less than minus x is same as z greater than x.
Guess when this is
And then I still don't understand what is your doubt. So you understand this part and you understand this part. So what's not clear? So
ma'am,
this part,
how it is equal to 1 minus probability of z less than x?
you understand this one? Probability of A is 1 minus or A complement is probability of 1 minus probability of A. This one you understand?
Yes, ma'am.
So from the same logic, this above one follows. Do you see that as well?
Okay.
Yeah. Probability of z greater than x is 1 minus probability of z less than x. This is the usual trick we do, right? We have done this earlier several times. What's different here? I don't understand. So is it because here you have z less than minus x and then you are doing 1 minus probability of z less than x? So is that why you get confused? What is the confusion?
No, ma'am, it's clear.
Okay. All right. So property 2 is something we have used several times. So you see that probability between two values you can compute by probability of z less than b minus probability of z less than a. Okay. So this way you can compute the probability between two values. And property 3, so this is something which we have not seen so far. So listen carefully. Probability of mod z greater than a. That means this blue area is what we are looking at. Okay. So we need to add the two areas together. So how are we going to do that? So it is probability of z greater than a, which is this part, and then probability of z less than minus a, this part. So both this part need to be added up, right? And we have already seen that the areas are same. So we can rewrite it as 2 times of probability of z greater than a. And again, we're rewriting it as 1 minus probability of z less than a. Okay. So this is also very easily understandable from the graph itself. Is that clear? Property 3? Okay.
Yes.
Let's look at some problems now. So before going to the problem, we should know how to read a Z table. So this is what you call as the standard normal table. Okay, so how to read this table? Okay, so for example, what is the probability that your Z is less than, for example, 0? Right, 0 means in your standard normal curve, what is the probability that everything is less than 0? We have already seen the answer for this. Since it is a symmetric graph, symmetric about mu, we have seen probability that z greater than 0 is same as probability of z greater than 0. Oh, sorry, less than 0. Greater than 0 is same as less than 0, which should be equally divided areas, right? So this is 0.5, this is 0.5, right? So you see 0.5 is something which we already know. Same way, probability of z less than, for example, let me say 1.2. So for that, sorry, not 1.2, 0.12. Okay, probability of z less than 0.12, you see 0.1 and then 0.02, 0.5478. Okay, can you all look at the table and try to read the value of probability of z less than 0.33? Can you look at the table and read the value?
0.6293.
Yes. 0.6293. So you all understand how to read the table, right?
Yes.
Now, what is probability of z less than 1.5? 1.05.
0.8531.
Yes, 0.853. Right? Okay. So
Ma'am,
this is
how it is?
how it is.
Yes, ma'am, I was
So
not able to see the values, 1 and 1.1.
1.05 is 0.8531. Okay. So
Yes, ma'am.
this is how we read the standard normal table. So if you know how to read the standard normal table, we can compute the values. Okay.
Okay.
Okay, now using normal tables to compute probabilities. So I have given the answers already, but let's try to verify it from the table. So probability of z less than 2.2. So let's look at the table for the value. For 2.2, what's the value? Can you see the table? Shall I zoom it? I don't know if you zoom it, you will be losing the top one. What is the value?
0.9861.
0.986.
Yeah, so it's 0.9861. Now, what is probability of z greater than 1.1? How do you compute this one?
1
1
minus
minus less
probability
than
of z
1.1.
less than
So what is probability of z less than 1.1? Just above you have the value.
0.
Sorry. Yeah.
1 minus 0.8643.
0.8643.
Okay. So if you calculate, you should get the above answer. Please check whether you are getting the above answer. Yeah.
Yes, ma'am.
Okay. So for the next part, probability of z less than 2 minus probability of z less than 0. What is probability of z less than 2?
0.9772.
So 0.9772. And this one,
0.5.
so what's the answer? Okay. Fine. Let's try more. Probability of minus 0.9 less than z less than 1.2. So this can be rewritten as probability of z less than 1.2 minus probability of z less than
Less than
minus 0.9.
0.9.
But remember, probability of z minus 0.9
will
can be rewritten
1
as
1 minus probability of z less than 0.
so we can rewrite this as. So first, what is probability of z less than 1.2? Let's look at the value and write it down.
0.8849.
0.8849. And this part is equal to 1 minus probability of z less
Less than 0.
than. Right? So this is minus 1 plus. Then probability of z less than 0.9 is
0.815.
8159.
now compute this and verify. Verify the answer, everyone. Is it matching?
Yes.
Yeah. Okay. So for the next one, how to do probability of z greater than minus 1.96?
2 into 1 minus probability of z less than 6.
But why 2 into? 2 into comes only for the modulus, right? Did you confuse with something else? Probability of
1
z
minus.
greater than, see, so z less than minus x is given. So I guess you confused with the other formula. Let's write it, break it down. So this probability of z greater than minus 1.96 is first of all 1 minus probability of z less than 1 point minus 1.96. Right? Now, how do we rewrite this z less than minus 1.96? 1 minus
1 minus probability of that. Yeah. Yes.
So this is probability of z less than 1.96. Right? So this is what we saw in the very beginning, right? Probability of z greater than minus x is same as probability of z less than x. Right? Probability of z greater than minus x is same as probability of z less than x. Yeah. So what's the answer for this? Less than 1.96. 1.9 and then there is your 6.
7.
0.975. So 0.975. Okay.
Madam, it should be z less than minus x, right?
Z less than?
Like the row you wrote the red color.
Earlier
Should
we
be
have
Z.
seen that. Yeah. So what we have seen earlier is this part. That these two are equal. So z less than minus x is same as z greater than x. Now it's the other way around. So now what we are saying is this. There is this. So now what we are saying is, so when you are having this standard normal curve, so this part is same as this part. So this is your minus x, this is your x. Okay?
Okay. Yeah.
Okay. Now what about the last one? Probability of z less than 0.72.
1 minus
So 1 minus probability of z less
z
than.
less than 0.7.
Probability of
What about 0.72?
So
1 minus
0.7642.
so 1 minus 0.7642. So should be 2358. Okay. So I guess by now you all can read the table very easily, right? No problem with reading the table and finding the probabilities. This part is fine for everyone, I hope, right?
Yes.
Yeah. Oh. So now standardizing to find normal probabilities. Okay. Now start by converting x into a z-score. Okay. The first thing to find the probabilities is that we are converting x into a z-score. Now the value of the standardized variable tells us how many standard deviation the original variable is from its mean. What does it mean? It tells us how many standard deviation the original variable is from its mean. Suppose your x is sigma. In that case, what is your z value?
0.
Oh, sorry, x is mu. If x is equal to mu, what is that you are getting?
No.
Z is equal to 0. Right? Now, here, suppose Okay, let's go back to this graph here. There is this, yeah. So here you see that your mu is here and mu plus sigma is here. Now when your mu becomes 0, this becomes sigma, this becomes 2 sigma, so just 1, 2 and so on. So here this tells us now this is like 1 standard deviation from sigma. Now this was 2 standard deviation, from not sigma, mu, from the mean. Same way this is like 3 standard deviations from mu. So in that way, Z tells you how far, how many standard deviations you are away from the mean value. Okay. Okay. So that is what is your Z score telling. Now we can compute any probability statement about writing X by writing an equivalent statement in terms of Z. Right? Because now what happens? Now your X less than A, X less than A. Suppose you are having X less than A. Now you see that X minus mu is less than A minus mu and sigma is positive. So you see that mu minus X minus mu by sigma is less than A minus mu by sigma, and hence the probabilities are now, so this is your Z. So probability of Z less than A minus mu is same as probability of this. These two probabilities are same. Okay. So instead of finding probability of X less than A, I can simply find probability of Z less than A minus mu by sigma, because for finding probability of Z less than A minus mu by sigma, I can easily do it from the table because I have the standard normal table. The Z table I have. So from the Z table, I can easily find the probability. Okay. So shall we try the following using the above formula, that is transforming X to Z and then using the standard normal table. Can we all try that for the next one? So what is given to us? You are having IQ examination scores for students of a particular school or normally distributed with mean value mu, standard deviation 10. What is the probability a random student chosen has a score greater than 30? So scores, let us say we are denoting by X. Now your score is greater than 130. So if X is greater than 130, what should be the corresponding equivalent condition in terms of Z? Z is greater than, remember Z is X minus mu by sigma.
Minus mu sigma.
So what should be here?
130
T
minus
minus 140.
by 10.
Yeah. So what is that we will get finally?
Would be minus 1.
Probability of
Z
Z
greater than minus 1.
minus 1. So what is probability of Z greater than minus 1? What is the probability of Z greater than minus 1? How do you compute?
1 minus
Here
probability
is
Z of
probability
1.
of Z
Less than.
Probability of
Z
1 minus probability of
less.
Z less than 1. And what is the probability of Z less than 1? How do you compute? Z less than 1, either you can use the bell curve values or you can use this table as well. So if you are looking at the table, then what you should get?
0.8413.
0.8413. So if you subtract it from 1, what is the final value?
0.16.
Okay. Fine. What about the second part?
We find for 150, then subtract from 1. Like 150 minus 120.
By the way, did we make any mistake here in this place? Z greater than -1 is same as probability of Z less than. What we have done here is correct only, right? Z greater than -1.
Should equal to probability of Z less than 1.
Yeah.
It should not equal to 1 minus.
Probability of Z greater than -1 is equal to probability of Z less than 1. Yes. It's equal to, right? Z greater than -1. So here minus X is 1 minus probability of Z less than minus X. So when we do this, this is what we have, right?
Yes, ma'am. Finally, Z less than X.
Yeah. So it should be probability of Z less than 1. So 0.8413. Okay. What about the second part? What is the probability a randomly chosen student has a score between 120 and 150? So 120 and 150. What are the corresponding Z scores for 120 and 150? So your mu is 140.
140.
So here -2 and Z equal to 150 minus 140 by 10. So again 10 by 1. So -2 and 1. So probability of Z less than 1 minus probability of Z less than -2. Now this is probability of Z less than 1 minus 1 minus probability of Z less than 2. So this is 0.8413 and 1 minus probability of Z less than 2 is 0.9772. So can you calculate this and tell the final value? What's the final value?
Then the probability of Z minus 2 is equal to, how it is equal to 1 minus probability of Z less than 2.
Yeah,
And how this is equal to this.
this is something we saw in the very early stage, I guess. Probability of Z less than minus X is 1 minus probability of Z less than X, right? Property 1. Yeah? Okay.
And it will be greater than.
This is property 1.
Yes, ma'am. Yes, ma'am. 1 minus, yes, ma'am.
Yeah, sometimes you may get confused. So do you get the final answer as 0.8185? How many of you get this answer? Anyone? Is there any confusion? Please let me know if you have any issues with the problem itself.
In this properties, madam, again, because it's more like greater than less than, it's very much confusing actually.
Yeah, we have to be very careful. So even in the previous case, I made a mistake, right? So here I wrote 1 minus p of Z less than 1. We have to be very careful. So apart from this confusion, the logic is fine for everyone, right? Shall we move on?
Yes, ma'am. The
Yes,
same,
ma'am.
same answer I'm getting.
Oh,
0.8.
Oh, good. good. Okay, now let x be normal with mean mu and standard deviation sigma. So find probability of modulus of x minus mu greater than sigma, that is probability of mod z greater than 1. Same way, probability of mod z greater than 2, probability of mod z greater than 3. Okay, so mod z, how are we finding this? How do we find this value? Modulus of something?
Greater
2
than
into 1
minus 1
minus
and,
probability of
and greater than plus
Z.
both, both the probabilities
And like
we have to consider.
So you do 2 into 1
2
minus
into 1 minus
probability of,
probability of Z less than
okay, so here probability of z less than 1, recently we wrote it, right? So it is 0.8.
0.841.
So can we cross check the answer now? So 2 into 1 minus 0.8413. What is the answer? You get the same answer, right? Yes or no?
Yes, ma'am.
Yes, ma'am.
Same way, 2 into 1 minus probability of z less than 2. What is probability of z less than 2? Even that we wrote now, right? Z less than 2 is 0.9772. So 2 into 1 minus 0.9772. You get it as 0.0456. Yes? Are we getting? Same way you can check this as well. Z less than 3. So what is probability of Z less than 3? Yes, 3 it's not given here. But it should be 0.997, right?
974.
So in that case, in all the cases, is the answer matching? Yeah. Shall we? Yeah.
Probability of less than 1 and probability of z is z less than 2. Then how we have calculated these values?
So already from the table, I have written it in the previous problem. So I just copied it from the previous problem. Otherwise, you can look at the table directly. So z less than 1, 0.8413, z less than 2, 0.9772 from the table. Okay.
And for Z less than that not Z greater than 3 for that particular thing, if Z less than 3 0.997 is coming out to be 0.005. So I think the Z less than 3 thing will be different.
That less than 3 should be this one only. Let me, so if you have to check the Z table, so let me just check the Z table value. So in Z table, it's 0.9987. It's not much different. In the Z table, it's 99. So since that value is not in this PDF, I just refer to Z table. So here, if you do this, are you getting the same answer? It's anyway, very mild difference only is coming. So 2 into 1 minus 0.997. 9987. 0.0026. Fine? Okay?
Yes, ma'am.
Okay. So the Z table values, if you have problems involving the Z scores, the table value will be given to you. Okay? Okay, fine. So, can we try the next question?
Yes,
So
ma'am.
already the answer is given. I should have, usually I don't add the answer, but by mistake in this slides, in every place I have added the answer. Okay, so here probability of X greater than 12 is probability of, now here your mu is 10, sigma is 3. So now here your Z is X minus mu by sigma. So if your X is 12, so 12 minus 10 by 3, so it is 2 by 3. So 0.67, right? Probability of Z greater than 0.67. So that is nothing but 1 minus probability of Z less than 0.67. Now what is the value of 0.67 in the table? Is it this one?
0.7486.
0.7486. Right? And you get the above answer. Fine? Okay. The next case, your Z is 13 minus 10 by 3. So now 3 by 3, so it's 1. So your probability of Z less than 1, it's 0.8413. We have seen this value several times, so this is fine. What about the last one? So Z is 11 minus 10 by 3. So 1 by 3, 0.67. No, 0.33. And then Z is 8 minus 10 by 3. So minus 2 by 3. So minus 0.73. So it means this is probability of Z less than 0.33 minus probability of Z less than 0.67. Now, everyone try the correct replacement for Z less than minus 0.67. You should replace it with, try it.
1 minus probability of Z less than 0.67.
Correct. Correct. So now what is 0.33? 0.33. 0.6293.
6293.
So you have 0.6293 and then 1 minus 0.67. 0.67. So 0.7486. So calculate all this and check the answer.
Yes, ma'am, it's coming out to be same 0.377.
Okay. So for the next one, again, now you have modulus. Okay. So for modulus case, so modulus of X minus 10 greater than 5 is equivalent to probability of mod Z greater than 1.67. Right? How are we doing this? Always remember that X minus mu by by sigma is greater than A. So how are we replacing? What is that we are replacing? What is it we are replacing in this case in place of Z? Yeah. What is it we are replacing? What is your mu and what is your sigma? Your mu is 10 and sigma is 3. Right? So here you have, this is your 5 times of sigma. So probability of mod X minus 10 greater than, so not 5 sigma. So this 5 is equal to A sigma, right? So this is how you have here. Sorry, I scrolled up too much. Where is that? Yeah. So this is A sigma. So that should relate to probability of mod Z greater than A. So what is your A? So your A sigma is equal to 3 is 5. So what is your A? A is 5 by 3. So 5 by 3, 1.67. So how we got this 1.67? Is that clear?
Yes.
Okay. Now probability of mod Z greater than 1.67. So that is equal to 2 times of 1 minus probability of Z less than 1.67. So 2 times of 1 minus, what is 1.67?
0.748. No,
1.67.
1.6.
Is it this one? Yeah, 9525.
952.
0.9525. So what's the final answer? Yeah, you get the answer, right? Okay. So everything is just understanding the uh, transformation between X and Z and then looking at the Z table. That's it. Okay. So I guess this is your last problem, if I'm correct. Yes, this is the last problem. I know we are crossing 8. So shall we just complete this one problem? Yeah.
Yes, ma'am.
Yes.
Okay. The scores on an entrance exam were normally distributed with mean and sigma. Okay. So mu is 500 and sigma is 90. Let X equal to the score on this scholastic test. So now if your score was 700, okay, by how many standard deviation did it exit the average score? So for this, what is that you need to calculate? Simply calculate the Z value because that tells you
Right.
how many standard deviations it is having. X minus mu by sigma. So 700 minus 500 by 90. So 200 by 90. So what is the answer? 200 by 90.
0.2.
200 by 90 is 2.22.
Yes, ma'am.
Okay, fine. What percentage of examination takers received a score than you did? So it means probability of Z greater than 2.
Greater than 2.
So what is 2.22? Just look at the table. 2.22, right?
0.986.
9868. So it means I have got almost the top score, right?
Probably 1 minus.
Sorry, what?
More than 2.2 you are calculating, right?
Oh, sorry. It means I have not got the top score the other way around. Sorry. So almost everyone scored more than me. So I am in the bottom row. Yeah. Okay, fine. All right. So in this module, there are quite a few topics more compared to the previous thing. But the thing is that everything is easily doable. So you just have to list down all the formulas and memorize it, and then you are done. Okay, so we have seen what is a continuous random variable, PDF, cumulative distribution function, and then we have seen all the different types of distribution: uniform, non-uniform, triangular distribution, exponential distribution, normal distribution, and in normal distribution, particularly the standard normal distribution, conversion from X to Z. Okay, that was very crucial. So these are the things we have covered in week 12. So I really recommend that everyone try to do the problems from week 12 before you come to the doubt session. Okay, so make use of the doubt session. So we will meet again on Tuesday. Okay?
And the table values will be given, right?
Yes, it will be given to you. No one expect you to memorize the table. Okay? All right, then. See you again on Tuesday. Thank you.
Thank you, ma'am. Bye.
Thank you, ma'am. Bye.